Well, you're going to tell me what you need. Can everybody find the surface area of this first one? Did everybody get 150? I don't need to show it, do I? Okay. What about 2? Did everybody get the surface area and the volume? You already checked these yesterday. You should have an X or a tick beside them. Do I need to do surface area? Yes. All right. Well, surface area of this. What shape is that? A triangle. Isn't it on the other side as well? So doesn't that make a rectangle of 6 by 8, right? So 6 by 8 gets me 48 for the front and back, yes? Okay. What back there? What is that rectangle right there? 6 by 7, which is 42, yes? Okay. What is that rectangle on the bottom? 8 by 7. Just listen, but watch.
For Thursday, January 9th, 2020. The following students, please come to the office at lunch for pickup. Sheila Rue, Mantaj Taylor, Preston Harris, Jessica.
But this is 90 degrees, so Pythagoras. How long is that? When you do Pythagoras, it's 10. 10 times 7 equals 70, and then you just add it up. Okay? Volume.
Senior and junior football gear hand in today after school in the Heritage Wing. Snowball tournament starts next week. Buyout game.
Isn't that the base?
B. Abbey versus Bateman. Buyout tickets
So,
$2 a piece.
what's its area?
For purchase starting Friday in
It's triangle, right? So it's 6 times 8 divided by 2, which is 24, yes? What's the height? Times 7. Yes.
You are interested in politics, policy, and international relations, simply looking to improve public speaking.
And then divide it by 2. You could have done that because that's half then. So what Addison is saying is, why can't he make that the base and times 6? Well, that would be fine if it was a whole prism, but it's not. And for the bazillionth time, the base is not the bottom. The base is the shape that repeats. And this triangle repeats again right there. Did everybody get this surface area? The number 3. Everybody got 192? Okay, what about this one? Did anybody get we'll do the surface area first. Did everybody get that one? I see some shaky heads and some naughty heads. All right, I remind you, if none of that was there, then don't you just have this? Right? And you could all do that one because you just did it here, right? And then, but this is here. So, when I color this pink and this pink, isn't that part of this? It is, isn't it? So the only stuff that was added was that green one, right? How many times was that green square added to this picture? Once, twice, thrice, 4 times, right? So, again, you can give us a formula for this, Mr. Myers, because there isn't one. You have to think. If I erase all this, like I did, and I make this, then it's 12 times 4 for the bottom, right? And there's 2 of them. 2, 12 times 4, plus, what's this one? Somebody who didn't get this right, what is this face right here? 4 times 4. So I've covered the front, the bottom, and the top. The two sides, what's the front? It's 12 times 4 again, right? And that covers this whole bottom, yes? And then all I did was add this how many times? Well, that is 4 by 4, right? So it's 16 times 4. And that will get me 288. Does everybody understand? Okay. Did everybody get volume? Volume had two ways. You could have done LWH on the bottom one, right? And then LWH on the top one, and then added them together, yes? Or you could have used what I taught you. The base is this shape, yes? Because that shape repeats, doesn't it? So if you found that area, which is 12 by 4, 48, plus that area, which is 4 by 4, 16, 48 and 16 is 64 times 4, because that's the height. Everybody cool? All right. E. Do we need to see surface area of E? I see a few naughty heads. Okay. Well, surface area here, I'll use colors. How many of those green rectangles are there? 2, because there's one in the front, one in the back. So I have 2 times 8 times 3. That's the green rectangles, yes? How many pink rectangles are there? 2, because there's one on the top and one on the bottom. 2 times 8 times 3. There's the pinkies, yes? Okay. How many purples? 1. 3 times 3. That's the purple one. How many blues? 1. 3 times 4. That's the blue. How many yellow triangles? 2. So isn't it actually a rectangle that is 3 by 4? Won't that cover the top and the bottom? So I need a 3 by 4 to cover that. And then now the only thing I haven't talked about is this rectangle right there, yes? And that rectangle, I think I'm out of colors. So that rectangle will have no highlighting. That rectangle right there is 3 by how much is that? You do know, because that's 4, that's 3, so you do Pythagoras, and that is 5. 3 by 5. Then you multiply it all and add it up. Why? Because there's no formula for it. Okay? What about volume? Doesn't that shape repeat? Does, doesn't it? This is 8 by 3, 24. This is 4 by 3, divided by 2 because it's half. So that's 6. What's 24 and 6? 30. What's the height? 3, 90. Everybody cool? Remember how I spent a long time talking about the base is any shape that repeats? Okay. F. Anybody need to see surface area of F? Yeah? Okay. Again, we'll use colors. How many yellow? 2. 15. 15 times 2. Yellow. Agreed? How many blues? 2. 15 times 5. That is 2 times that. That is 2 times that. Agreed? How many greens? How many? 2. 2 times 8 times 2, right? 8 times 2. What? Oh, okay. Let's print it differently. That's fine. It's no problem. So you guys have that there. Okay, so that means that is 5 by 5, right? How many of them are there? 2. But since it's a triangle, it makes this, doesn't it? So what is 5 by 5 for that whole square? 5 by 5 covers that whole square, yes? Okay. So what's missing now? What's the only thing I haven't colored in? The bottom, right? What's the bottom? Eight by 15. Are there 2 of them? No, because this ceiling is on top, right? So all you do is multiply that up and add it out. Right? Okay. What about volume? Well, again, doesn't this shape repeat to back there? Right? So what is this area? Well, that's 8 by 2, which is 16. And that's 5 by 5 divided by 2, which is 12.5. So that's 28.5 times 15. Which I don't think will actually give you 420. I did this with no right angle there. So I get a slightly different answer. If you have the right angle there, it's going to be 12.5 times, or 28.5 times 15. Without the right angle there, oh, there it is. Without the right angle there, then of course, this is 5, this is 4, so this height is 3. So it's 4 by 3 divided by 2. Or, sorry, 8 by 3 divided by 2. This would have been 12 times 15. Or 12 plus 16 would have been 28 times 15, which gives you 420. Okay? Surface area here. Here is how I do this surface area. I pretend like this is a whole thing. And I do that surface area, right? So that's going to be 2. And it's going to be 22 times 4, because this is 4 high, right? Plus 22 times 6, because that's the top. And then plus 4 times 6, because that's right here, 6 by 4, right? But it's not that, is it? But isn't this and this still there? It is, isn't it? And isn't this and this still there? So the only thing that's missing from this is that red rectangle, right? And how many of them are there? 2, because there's one there and there's one there. Those are what's missing, right? Those are 11 by 2, which is 22 and 22. So I do this minus 44. Does everybody understand why? If I take this part that I'm coloring in blue and I lift it up to here, it becomes the whole roof, doesn't it? And this wall, if I stretch this out to here, there it is, isn't it? So the only thing missing is that little green rectangle there, right? If I make this whole, the only thing missing is that little green rectangle. So I subtracted it out. Why? But it is there. It's there and it's there. No, Braden, it's not okay to do that. Look. It drives me up the wall when you guys do that. There is this, isn't it? Right? That is right here, yes? Okay. Is this whole roof there? Okay. Now, I'm going to just draw a line there. Is that roof still there? Is that still there? Okay. Now look over here. There's that roof. There's that roof. It's still there. It's just been dropped down. If I were to pour paint over this block, here it comes, would it cover all that? Would it cover it all here? So you don't subtract it out. If I continue to pour that paint over here, will it cover this entire wall? Yes, it will. But if I continue to pour paint on here, will it hit that green rectangle right there? No, because that isn't there. So I subtracted it out. Do you understand? Okay. Everybody else understands? All right. Oh, volume. Sorry. Again, you can do it the long way, or you can do it the way that I spend not a million, I said like 5 times. Doesn't this shape repeat? Okay, so if I know this area and I multiply by 6, do I know the volume? How do I find this area? Well, it's 11 by 4, which is 44, and 11 by 2, which is 22. So it is 66 times 6, because that's the height. Everybody good? How can that be the height when it goes backwards? Because it's the one that's going 90 degrees away from the base. The base is the bottom, Addison?
No, it's the side that extends.
It's the side that repeats. Yes, Addison.
Can you not do the same thing that you did with the surface area and make it a whole box? And then
Addison, it's like you're in my head. Get out of there. I was just going to say that. Could you make this whole and do 6 times 4 times 22 and then subtract out this section, which would be 11 times 6 times 2? Could you do that? And would you get the same answer? Mm-hmm. Of course you would. Do you all see why I only gave you formulas and how to build them? Because some of you will think of it and do what Addison did. Some of you will think of it and do what I did. Some of you will find this volume on the left and this volume on the right, and then add them together. Is any one of those 3 better than the other one? No. And if I show you all 3, then you guys haven't done anything, have you? Right? I want you leaving here thinking. And I think that's it, yeah? Oh, no. Well, this guy... Oh, yeah, that was it. Oh, the paint. We got to talk about the paint. Now, everybody made some good decisions here because I eavesdropped on your talking. 1 gallon of paint is 300 square feet, right? Except I'm an idiot, or Jim's an idiot, and he measured his room in meters. He only had a metric measuring tape, which is possible. I happen to have a metric measuring tape. It's only in centimeters. All right? So what's the problem here? You got to convert, right? Okay, so there's 2 ways you can do this. There's an easy way that will take you a long time, or there's a way more difficult way that I never taught you that you have to bring your brain to the party. Everybody with me? We'll do both, okay? The easy but long way. First of all, we are only painting the walls. Okay? We're not going to bother with the ceiling. Everybody cool? So how tall is this room? Read the question. 3 meters. So I got one wall that is 3 meters tall, and how long? 4.1. Agreed? Agreed? And I got my second wall is 3 meters tall, and how long? 5.3. Agreed? And of course, there's 2 of them and 2 of them. Because it's not a TV show. There's 4 walls, right? Okay. Now, in the easy but long way, I should convert that and that to feet. Everybody understand? How do I do that? 4.1 meters. I want feet. So feet goes up here. 1 foot is 0.3048 meters, right? So it's divided by, agreed? So 4.1 becomes whatever it becomes. 13.5 feet. So this is now 13.5. Agreed? Even if you didn't do this way, I do want you to be able to follow me. Is everybody good? Okay. 3 meters divided by 0.3048 is 9.8 feet. So this is now 9.8. And 5.3 divided by 0.3048 is 17.4. Now, can we find all the square feet? Yes or no? How do I find this square footage now? So the red walls, what is it? 13.5 by 9.8 by 2. And the blue walls are 17.4 by 9.8 by, and that's going to give me my square footage, yes? Should have done that red. 264.6, and in blue, 341.0, because it's 0.4, right? And then you're going to add that up. Is going to get you 605.64 square feet, yes? How many gallons of paint do I need to do that? Well, 1 gallon does 300, yes? So I divide that by 300, and I get 2.02 gallons. Because the paint is sold by the gallon, I got to buy a 1/3 gallon of paint. Or I'm going to leave a little corner unpainted. Yeah, which is 2.0. Oh, damn it. It does say to the nearest 10. Son of a bee. Grr. Forgot that was in there. Now, that's the easy long way. There's a much shorter way. 4.1 by 3. 5.3 by 3. Do it with meters. 4.1 times 3 times 2, 24.6. Yes? 5.3 times 3 times 2, 31.8. That should have been blue. Agreed? Add it up. 0.4, carry the 1, 6, 56.4 meters, right? meters what? Meters squared. Agreed? Now, I got to convert that to feet. Now, this is where everybody makes a mistake because they're not thinking. You looked on your chart and you see 1 foot equals 0.3048 meters, right? Everyone agrees? So if you're not thinking, you say, oh, that's easy. I just divide that by 0.3048, right? But it's not. Why isn't it? Addison. Meters squared is different. Let me show you what I mean. Look, I have it right here. But I'm going to erase it and show you what I mean. 1 foot by 1 foot. What's this in the middle? 1 foot squared. 1 times 1. Everybody understands? Okay. How long is 1 foot in meters? Carmen just got it. How long is 1 foot in meters? How long is 1 foot in meters? 0.3048. So how long is this in meters? 0.3048. So how much is this? It's that times that, isn't it? Which is 0.09 blah, I don't remember. When you're converting more than one dimension, you must convert it how many times? If you're going from a straight line to squared, you would convert it twice. What if you're going from a straight line to cubed? You would convert it thrice. So this, I have to do this divided by 0.3048 squared. Because I'm converting square meters. Does everybody understand? But see how you can do it in way less steps? Now, don't make the mistake that a lot of my kids in the past have made. Say, oh, you're filling up the room, you're painting all the walls of the inside. That must be volume. When you paint a room, do you fill it with paint and then open the door and drain the paint out and then there's paint on the walls? Yeah, buddy. No. It is surface area. Everybody cool? Do not fill the room with paint. Yes? Okay. Let us move on then, cabbage. What are we on? We are on spheres, are we not? Which is page 215. Now, spheres, ladies and gentlemen, there's no way to draw them, right? Because all a sphere is a single circle spun around infinitely, right? There's no way to draw it out flat. Because if you squish down a sphere, what do you get? A circle. So you can't draw it. Everybody cool? So as a result, there was no formula, no way to build a formula the way we've built the other ones, right? Like it's obvious a cylinder is circle, circle, rectangle, right? It's obvious that a pyramid is rectangle, 4 triangles, right? Spheres, we didn't have that luxury. So we used experimentation to find these answers. All right? Now you have to look at this carefully. Or both of these work. If you have a diameter, you can just do pi d squared. If you have a radius, you do 4 pi r squared. Everybody cool? All right. Then over here, this is the way we always write it, but I don't like writing it that way. Because when you write it that way, you guys see a fraction, it gums you up, yes? So I like to write it this way. 4 pi r cubed in brackets, so you do all that first, and then what? Divided by 3. Everybody cool? Now there's only one weird thing that can happen here. If I have a sphere and I cut it in half, because that's a word we use all the time, hemisphere, right? What is the surface area? Well, most kids say, well, if it's that is a whole sphere, then I would just divide it by 2, wouldn't I? Right. So that would be 2 pi r squared, yeah? Except when I cut it in half, what did I just make right there? A circle. A new surface. I just screwed that up. You said surface. I thought you said circle. Let's rewind. What do I have there? A surface, which means I have to add that surface, don't I? Because it's new. What is that surface? A circle. So I have to add another pi r squared. What's 2 pi r squareds plus 1 more pi r squared? 3 pi r squared is the surface area of a solid hemisphere. Everybody cool? Now, what if it's a hollow one? Like a bowl. What would the surface area of a bowl be? So imagine I'm not carrying a bowl. Let's pretend this is a perfect sphere of a bowl, yes? If I dipped this in paint, where would the paint be? Everywhere out here and everywhere in here. So isn't the surface area of a hollow hemisphere the exact same as the surface area of a sphere? Because if I pulled that inside out, I would have the whole sphere, wouldn't I? Imagine a basketball with no air in it. If you push it down to make a hemisphere, a bowl, is the surface all still there? Everybody with me? So a hollow hemisphere has the exact same surface area as a full-size sphere. But a solid hemisphere is half plus that new circle. Everybody cool? All right, now what about volume of a hemisphere? A hemisphere is half a sphere, yes? Yeah. So I would multiply this by what? By a half. What's 4 pi r cubed times 1? 4 pi r cubed, all right? I'm not fooling you. What's 3 times 2? 6. And then I see 4 on top and 6 on the bottom. So what do? Mrs. Bad Crumble's class, would she ever let you hand that in as a fraction and give you a mark? What is it? How do you simplify that? 2/3. So 2 pi r cubed divided by 3. So that is the volume of a hemisphere. Is everybody cool? Yeah? Yeah? Okay. This question is stupid. I don't know why I keep it in there. Actually, I do know why I keep it in there. It makes you practice algebra. So let's have a look at this. She's wrapping up a basketball for her brother. She's a stupid head. She didn't put the basketball in a box. She's trying to wrap a ball. That's dumb. Right? But because she's dumb, we're going to do the math for it. First of all, is this going to be surface area or volume to wrap up a basketball? Surface area. So I go to my formula. Surface area equals 4 pi r squared. Yes? Right? Okay. What do I know now? Read the question. Tell me the info that I know. Well, there's only 2 variables here, isn't there? R and surface area. Which one do I have? I have surface area, don't I? Because the wrapping paper, she needs 2,500 centimeters, right? So where does 2,500 go? Surface area or radius? 2,500 equals 4 pi r squared. Now, how will you tell me what r is? What do you have to do? Algebra. Isolate r. So, where do we start? How do I get to r? What do I got to fight my way through? I got to fight my way through 4 times r. So how do I get rid of 4 times? Okay, I've defeated 4. Now what do I got to fight through? Excellent. Good. Now what do I got to fight through? Pi. I got to fight through times pi. So what do I do?
Divide by pi.
Divide by pi. I fought through pi. Divide by pi. Yum, I'm full. Now what do I have to do?
What?
What's in the way of r being alone now?
Exponent.
A squared. How do I fight through a squared?
Square root.
I square root. So what do I do here? What do I do here?
Square root.
Square root. Now, am I happy with that? Have you shown me all the algebra you could do? That's all the algebra we had to do, right? Now, in real life, we're just going to punch that into our calculator, right? 2,500 divided by 4 pi. Yeah? So everybody try to punch that into their calculators now. And you're going to see something weird. A lot of you are going to get weird answers. No matter what your answer is, say it out loud because I have a point that I'm trying to make. So everybody try to punch that into your calculator any way you can figure it out.
Great. Punch it into your own calculator. Don't just copy what I'm doing.
So, Rylan, what'd you get? So 796. Keep talking. What?
I think I got 795.7.
So yeah, what he got. Gersa, what'd you get?
I got 3.9788.
3.9. So let's call it 4.
I got pi 25.
25 times pi? Because your calculator just shows pi?
No, I just didn't do it.
Oh, you didn't do it? Okay, that's cool, that's cool.
Because you wanted math answer.
No. I said I wanted a real life answer.
Oh.
That's why I said punch it into your calculator.
Okay, then I'll do the actual answer.
What? Well, we have that. 796. It's 795.7, so it's 796. Huh? Okay. Addison.
14.10.
14.1. Party. 44.3. Braden.
78.5.
78.5. Now listen, please. How many possible radii can a basketball have? 1. How did we get 6 different answers? Everyone did it differently because you don't actually know how your calculator works, yes? All right. What is that acronym that you learned in about grade 6 for how to do math? BEDMAS, right? What does this expression mean? It means 2,500 divided by, not by 4 pi, divided by 4 times pi. If you punch into your calculator 2,500 divided by 4 pi, it does BEDMAS. It's going to do 2,500 divided by 4 and then multiply that answer by 5 because your calculator doesn't think. It does what you tell it to do. So you got to put brackets there. So everybody do that. You get 198.9, yes? Now, what does that green symbol mean? We square root 198, which is going to be 14. Who got 14? Pardeep? I thought you were 44. Now, yeah, everybody should have gotten 14 now. Addison got 14?
Is there a pi button?
Yes, on almost every calculator.
Which one does
The one that has a pi by it. Now, Braden said, haha, I know, Myers, you're not fooling me. He wants to do this the proper way, right? Well, what's the square? This is really the square root of 2,500 over the square root of 4 pi, yes? What is the square root of 2,500? 50. What's the square root of 4? 2. Is there a square root of pi? So you have to leave that square root pi there, yes? What's 50 divided by 2? So it's 25 over the square root of pi. Yeah, that's close to what you got. It's just because you did it wrong, but you were thinking about it that way. Now, if we were in grade 11, we would not be allowed to leave a pi there, a square root on the bottom. So you would do more math with that, and your final answer would be 25 pi over pi. Sorry. It would be 25 root pi over pi. If we were in the 11th grade, that would be the best answer you could give me. But you don't need to worry about that, so don't. Everybody cool? So what is the key? What are we taking away from this? If something's like that, just like it is here, you got to use brackets, or it's not going to give you the right answer because your calculator is going to do BEDMAS. Everybody understand? Okay. Now you try it. Let's look at number 2. This is tricky. This is all we're doing today. Oh, I lie. This is not all we're doing today. I'm packaging golf balls. Because, of course, you all know stuff comes in packages, yes? What? Jim is a busy guy. Hey, he's painting his house. He's packaging golf balls. Right? Jim didn't want to paint, so he just put a hose in an open window, just filled the room with paint. All right. So, now some of you people are like, Mr. Myers, this is so stupid. Why are we even doing it? Of course, because all this math gets done all the time, right? When you buy a product, right? You buy a stereo. It's in a box, yes? Are those boxes free? Somebody has to pay for those boxes, yes? Everybody understand? So if I have a box that's way too big, I'm paying too much for it, right? But who's really paying too much for it? No. Nobody cares about the earth. That's why people still think climate change doesn't exist and why we still drive our cars to 7-Eleven to get plastic straws in our plastic cups. Okay. Now, once again, who really pays? Addison? The consumer pays, right? Because if I am trying to sell you guys grapple grommets, it's just, they're not real. It's just a word. If I'm trying to sell you grapple grommets, they got to come in a box, yes? I got to pay for that. I want to pay for that, so I pass those costs on to you. If I can cut my costs, you get less price, yes? It costs me less to make something. Of course, what really happens is they cut costs everywhere they can and then still charge you the same amount, right? Because, of course, you all know an iPhone 11 has about $300 worth of stuff in it. But they charge you $2,500 for it. What's a thing? Well, I've never known what a grapple grommet is. I've always said it as a joke. I know what a grommet is. I don't know what a grapple grommet is. You know those things that are in tarps? Like when you go camping, those metal things that you put the ropes through? No. That's a claymation cartoon from the United Kingdom, and it's not spelt the same. All right, anyway. So, we do this math because things like packaging do matter, right? And also what Braden said, the less packaging we can use, the better off we are. So, we're going to package our golf balls, 3 of them, in this cardboard box, right? Okay, so if the balls fit perfectly snugly, find the volume of empty space, because we don't want empty space if we can avoid it, right? So, there's 1 golf ball, there's 2 golf balls, there's 3 golf balls, right? How long are they? Or how big are they? They're 3, right? 3 and 3. Agreed? And they're going into this cardboard box. which is how big? 3 by 3 by 9, yes? How do I find the empty space? What math am I going to do?
You gotta find the circular, volume of the spheres and volume of the box.
And then what?
Subtract. Times the spheres by 3.
So it's volume of the box minus 3 volume of a sphere to get the empty space, yes? How do we do the volume of the box?
Find 3 times 3 times
Length times width times height, right? Minus 3. What's the volume of a sphere? 4 pi r cubed over what? Over what? We just wrote this down. 3. Hey, wait a minute. What's 3 and 3? What happens? So by showing work, you're doing less work, aren't you? I know, crazy, hey? 9 times 3 minus 4 pi r cubed. Now, can you punch that in? Oh, wait a minute. What's r? 1.5. Can you punch that into your calculator and get the right answer? Do you think? Some calculators will do this right, because in BEDMAS it will do this exactly right. Is there a way you can make sure? Brackets. But all of your calculators should give you the right answer here. I'm interested to see. So everybody punch in just what you see. 9 times 3 minus 4 times pi. You do. Times 1.5 cubed. What do you get? What do you get? 38.6. What are some other answers? I want to see if we're getting it. 38.6. 38.6. Why is this one okay? Because there's no division. Right? There's nothing in the way.
Okay.
Now, if you didn't show me your work and you just went that times 3 and you tried to punch it all into your calculator, now you've got some division. Is there a chance it'll screw you up? Yes. And what will all of you do? Write down the answer on your calculator because you aren't thinking, right? The calculator said so, it has to be right. Like back here, when your calculator told you that it was possible for a basketball to have a 700 centimeter radius. The basketball is 14 meters wide. Some of you would have written that on a test. And since I'm a nice guy, I would have just gone wrong. But when we went over it, oh, would you hear from me? I would never use your name, would I? But I would be, wow. The Raptors game wouldn't be as good if the basketball was 14 meters wide, would it? I don't know. You guys may be aware of this. You might have seen one, Ryland. You can buy giant rugby balls. They're like the size of 2 of these desks. You can throw them like maybe I could throw it maybe to Hannah. And if I had a real rugby ball, I could throw it like down the hall. It's so fun because you can't even run with them, right? Because you got to hold them like this. Yeah. You look like, yeah. It's like playing rugby in a sumo suit.
There's a kid on my team, Brady.
Yeah, I know Brady. I know Brady well.
He's a great guy. I've seen him run with that.
Yeah, it's hilarious. Brady is like 4.5 feet tall. He's in grade 10, but he's like 4.5 feet tall. He's a super good player. Yeah. His sister's way bigger than him.
I know it, and she's quite a bit younger.
Yeah.
Wait, Brady lives in Maple Ridge, right?
Yeah.
I do.
How do you know Brady?
I go to the gym.
Huh. All right. It's 11:11. Make a wish. Okay, listen. This is really hard, and we're running out of time. Okay? Give it a shot if you want, or you can wait till tomorrow. Page 217 and 218 and 219 and 220 are what I want done by Monday. Okay? Everybody good? Tomorrow in class, we're going to be working on 221
Okay, what is it?
up to 220 is what I want done by Monday. Tomorrow in class, we're going to do 4 questions, page 221 to 223. That's it. But you're going to work on them together, and there's going to be a race.
What do we win if we beat everyone else?
Huh? There'll be. I have no doubts. I can say this. There will be a prize because not one group is going to get all 4 of those questions right.
You want to bet? What if I do them at home?
You won't get them right. No, you're not supposed to do those ones at home. They are supposed to be in class.
Hey, goggles. Hey, Google.
It would be cheating.
Answer to that.
All right. I can't remember when class actually ends. 11:25. Oh, look at that. You got 12 minutes to work right now. Man, I'm the nicest guy in the world.